Hello! Today in your Algebra 2 lesson from the van, we're going to be talking about linear quadratic systems, again like we did yesterday, only today we're going to solve them algebraically. Graphing is limited in that it doesn't necessarily tell you exactly where something is happening. Even if you use Desmos, you only get a couple of decimal places, and we know that like if something happens at an irrational number, it's better to have that answer in square root form because then it's considered an exact answer rather than the decimal estimate. So the graph is good to verify your answer and make sure that it makes sense with what you're finding algebraically. So we'll do that today, but we're going to be solving them algebraically. So our two basic strategies of substitution and elimination are still fair game. That's how we solve systems. So we'll be using those today. I have some steps written down here for you. So the steps you will be using is you'll use substitution or elimination in your system. Then you'll simplify what's left. Remember, if you're going to solve something with a quadratic equation, that means I have an x squared involved today, you need to have an equals 0 on one side of your equation. So there's a reminder there for that. And then you can try solving by factoring, or you can use the quadratic formula if it's not going to factor nicely. So we'll go ahead and get those written down. You can pause my video if you need to, but let's go ahead and begin here. So we have our first example has y equals 1/4 times the quantity x minus 3 squared as our parabola, and our line is going to come from 3x minus 2y equals 13. So I would like to solve this with substitution today. I noticed in my first equation it says y equals, so if you have y equals blah 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 or x equals blah blah blah, remember that means you can make a trade happen. You can take the y and replace it with whatever it's equal to. So that's what we're going to do here. So let's see, I'm going to write on this. So I'm going to take the y, ooh, that doesn't look good. I'm not going to draw boxes around it. I'm just going to underline. Y is equal to all this stuff. So I see a y in my second equation, so that's where I'm going to do the substitution step. So I'm going to take my second equation, 3x minus 2, only instead of putting the y there, this is where I'm going to make the trade happen. The rest of the equation says equals 13, so I'm going to get that written down, and then I'm going to go ahead and fill in my box with, instead of a y, I'm going to replace it with 1/4 times the quantity, x minus 3 squared. So I'm filling in. That's the substitution step. So now this resulting equation is kind of a disaster right now. So we have some simplifying to do. We have some work. First of all, I notice right here, I have 2 times a fourth. So if I take 2 times a fourth, I would get a half. So I'm going to simplify this down a little bit to 3x minus a half times this x minus 3 quantity squared equals 13. So that looks slightly better, not really a whole lot, but slightly better. So I have parentheses, so that draws my I right here. So that x minus 3 quantity squared means I need to take x minus 3 times another x minus 3. That binomial is times itself. So that's what we'll work on next. Minus 1/2 times, oops, we'll do this in green. So x minus 3 is going to get multiplied by another x minus 3, and that's equal to 13. So if I multiply out these binomials, I'm going to have an x squared. From this, I'll have a minus 3x and another minus 3x. So that will make minus 6x in my middle term. And then when I take the negative 3 times negative 3, I'll get a positive 9. And then I still have this equals 13 hanging on the end here. Okay, well, I suppose there's not any parentheses that are getting squared, but I still have parentheses. So now the distributive property is going to kick in. I had to do the exponent first before I distribute because distribution is multiplication, and I'm thinking order of operations here. But now I can distribute. So let's take this negative a half and multiply that out. So I'm going to have 3x and then it'll be, let's see, minus 1/2 x squared, and then the negative times negative will make it a plus 3x. Half of 6 is 3. And then if I take the negative 1/2 times that 9, I'm going to have negative 9/2. Yes, you could put 4.5. Yes, you could put 4.5. Those are all equivalent. I like the improper form better. Okay, so it's getting a little bit better. Still not great. Do you see anything you could simplify there? Well, I see the 3x's. I could put those together. Let's do that. That'll look slightly better. I like to have my highest exponent first. So I'm going to put my negative 1/2 x squared first. And then we'll go ahead and combine these like terms. So that's going to give me a plus 6x. And then I'll bring down this minus 9/2. And my equals 13. Okay, so the two things that I notice now is that, well, I have fractions, that's a pain, and I don't have my equal 0 yet. That's not good. So let's take care of those two things. I think I'm going to clear out the fractions first. Now, this step is not necessary. You could keep the fractions in, but I don't like them, so I'm going to make them go away. The thing that makes a fraction is the denominators. So I don't like the divided by 2 part, so I'm going to multiply every term here by a 2. So that means I can cancel these. Oh no. So I have negative 1x squared plus 12x. I can cancel, plus minus 9 equals a 26. So if I look at this, okay, so this is getting closer to something I can work with here. I need an equal 0 on one side of my equation. So I'm going to subtract 26 on both sides of my equation. Don't drive. So minus 1x squared plus 12x minus 35 equals 0. Okay. Now I don't really like having a leading coefficient of -1, so I'm going to go ahead and multiply through by a -1. All that will do is change all of my signs, and the 0 doesn't even do anything. So I currently have 1x squared minus 12x plus 35 equals 0. So that is a quadratic we can work with here. Now remember, it's nice to try factoring first. If factoring doesn't work, then you can resort to the quadratic formula. But this one is going to factor very nicely. To get the x squared, we're going to have an x and an x. The signs are going to be the same. I know that because I'm looking at the positive in front of the 35 there. They're both going to have to be minus signs, so I'll put those in. Now to get that 35 for multiplying, you could have a 1 times 35 or a 7 times 5, and 7 times 5 is what's going to work here. So we have it factored, so now we are ready to use the zero product property. So if I use the zero product property here, one of these factors, either what's in the red box or what's in the blue box, has to equal 0. It's the only way you're going to get that 0 answer. Is if one of those factors is 0. Well, what if it's the first factor here? What if the x plus 7? Oh, no. What if the x minus 7 is the one that's the 0? Well, when you add 7 on both sides, you're going to get an x value of 7. The other option is maybe it is the blue box, the x minus 5 is the one that's the 0. Well, if you add 5 on both sides there, you're going to get an x value of 5. Now, we got to keep our goal in mind. If you remember, what we're doing here is we are solving a linear quadratic system. So what we're looking for is 2 ordered pairs. What we have right now is 2 x values. So we know the x coordinate of each of these intersection points. So there are going to be 2 points where our parabola and our line meet, and we know the x values. So to find the y values, we're going to have to plug that in to one of our original equations. I think I would rather use the linear one. So 3x minus 2y equals 13. So let me bring that down here. 3x minus 2y equals 13. So if we plug the 7 in, so I'm going to put the 7 right here. So we would get 21 minus 2y equals 13. We'll subtract 21 on both sides. So negative 2y equals negative, let's see, what is that? 8. And if we divide by negative 2, we get a y value of 4. So there's one of our points. Now I'm going to use that same equation. So the 3x minus 2y equals 13. I'm going to use it again, only this time I'm going to plug the 5 in. So 5 is going to go in here. So I'll have 15 minus 2y equals 13. I'm going to subtract my 15 on both sides, and we'll get negative 2y equals negative 2. I divide both sides by negative 2. We get a y value of 1. So my other intersection point should be at 5, 1. So we have an intersection point at 7, 4 and an intersection point at 5, 1. Let's see if our graph verifies that. I happen to have these graphed over here for us. And if we look, oh, there's 5, 1. Look at that. 5, 1. And the other one is 7, 4. So we did it. We solved that system of equations algebraically. So I'll do another example on the next video.